After making the calculation mistake, it was gr over here instead of gr theta, and then combining all the terms, I get this. This is the expression for fxx in terms of r theta and the partial derivatives of g. Now similarly we find the expression for fyy. So we have already calculated fy. So fy we have calculated above, that was sine theta gr. So fy we have calculated 4 plus what was there, this is 1 over r cos theta g theta, 1 over r cos theta g theta. So this is the expression we have got for fy, and now we want to find its derivative with respect to y once more. So let's apply the derivative with respect to y once more on both sides. So it will be partial y applied on fy is equal to partial y of the expression sine of theta gr plus 1 over r cos theta g theta. And now this is clear that this expression is directly not depending upon y, so we have to apply the chain rule, and on the left we can write fyy, and this will become partial by, okay, because we can apply the partial chain rule both with respect to r and theta, because y is ultimately depending upon r and theta both. So it will be partial r of this sine theta gr plus 1 over r cos theta g theta, and here it will be partial r over partial y this time, plus again it will be partial theta of the same expression, which is sine theta gr plus 1 over r cos of theta g theta, and here it will be partial theta by partial y. So this is the chain rule we have to apply. Now I plug the derivative, I calculate the derivatives of the whole expression by plugging these values of partial r by partial y and partial theta by partial y. So this will be distributed. So it will be applied to partial by partial r onto sine of theta gr plus partial by partial r applied on 1 over r cos theta g theta, and there is this expression partial r over partial y. And for the second expression I go over here, so I apply this derivative with respect to theta on this expression. So this will be partial by partial theta sine of theta gr plus partial by partial theta 1 over r cos theta g theta, and then this expression will be outside, that is partial theta by partial y. So let's calculate this derivative. Here you can notice that sine theta is constant with respect to r, so that sine theta will be as it is, and the derivative of r with respect to r, gr with respect to r, it will become grr. And in the second expression, if we notice that this cos theta is a constant with respect to r, so that 1 over cos theta will come outside, and the derivative is to be applied only on the other two expressions, which are 1 over r g theta, and for that we have to apply the product rule, but I will be applying in the next step. But now I write the value of this partial r over partial. The value of this partial r over partial y we have already calculated, that is y over r. Now I go to the second expression in this bracket. So here we have sine theta, which is also depending upon theta, and gr is also depending upon theta, so I am going to apply the product rule over here. So the derivative of sine theta will be cos theta, gr will be as it is, and then sine theta will be as it is. Derivative of gr will be taken with respect to theta, so it will become gr theta. And in the second expression, because we are taking derivative with respect to theta, this 1 over r is just a constant, it will be taken outside, and derivative with respect to theta will be applied on cos theta g theta. and then I plug the value of this partial theta. The value of this partial theta or partial y we calculated before is basically x over r square. And now we further carry out the calculations. In the first one, that will be sine theta g r plus 1 over cos theta will remain as it is. And now here I apply the product rule on this one. So the derivative of 1 over r will be negative 1 over r square, g theta will be as it is, and then 1 over r will be as it is. Derivative of theta, g theta with respect to r, it will be g r theta. And here the value of y we know it's r sine theta, so it will be r sine theta divided by r. Then I go to the next part over here. So we have cos theta gr plus sine theta gr theta plus 1 over r, and again here we have to apply the product rule with respect to theta. So the derivative of cos theta will be negative sine theta, and g theta will be as it is, plus cos theta will be as it is, and derivative of theta with respect to theta will be g theta. And then we simplify this expression after that bracket. So x is equal to r cos theta divided by r square. Okay, so this will be sine theta grr negative 1 over r square cos of theta, so it will be negative over here, negative 1 over r square cos theta g theta, then plus 1 over r cos theta g r theta, and there is multiplication outside with only sine theta. And for the second expression, it will be sine theta g r, sorry, I have to write from here. It is cos theta gr plus sine theta gr theta, and here we do the multiplication, so it will become negative 1 over r sine theta g theta plus 1 over r cos theta g theta theta, and here is the multiplication. Here r square is cancelled, so it will become cos theta over r. Let's multiply this whole expression inside. It will become sine square theta grr negative sine theta cos theta over r square g theta, and then plus sine theta cos theta over r and g r theta. And when I multiply with this expression over here, it will become plus cos square theta over r g r plus sine theta cos theta divided by r, and here it is g r theta, then negative sine theta cos theta over r square g theta, and plus cos square theta over r square g theta theta, on multiplying these expressions. And now we combine the like terms. On combining the like terms, I write the first term sine square theta gr as it is, and these two are like terms, so they will become plus 2 sine theta cos theta over r gr theta. Similarly, we have these two like terms, this one and this one, they are both are of g theta, so that will become negative 2 sine theta cos theta divided by r square g theta. And finally we are left with the last two terms. I just write them. So one is cos square theta over r gr, and the last one is cos square theta over r square g theta theta. So this is the final expression for fyy.